So today we are going to be discussing energy and momentum. Firstly, energy. What is energy? Energy is defined in physics as the capacity to do work. There are different types of energy, but the two we will be focusing on today is kinetic energy and potential energy. Kinetic energy is energy that is obtained by an object due to motion. The equation for this type of energy is kinetic energy is equal to 1/2 mv squared, where m equals mass and v equals velocity. Potential energy is energy that is obtained by an object due to position or being squashed or stretched. Potential energy that is obtained due to position is called gravitational potential energy. The equation for this type of energy is potential energy gravitational is equal to 1/2 mgh, where n equals mass, g equals gravitational constant, or 9.81, and h equals height. Potential energy obtained through an object being squashed or stretched is called elastic potential energy. The equation is potential energy elastic is equal to 1/2 kx squared, where k equals the spring constant and x equals the displacement of the object. One example of kinetic energy and potential energy can be seen with a roller coaster. At the bottom, the coaster is moving but is not high off the ground, meaning it has no potential energy, but it does have kinetic energy. When the roller coaster is on the top of the hill, it stops for a second. It is high off the ground, so it has a lot of gravitational potential energy, but no kinetic energy. This example also connects to a key concept of physics, the conservation of energy. The conservation of energy states that energy can neither be created nor destroyed, only transformed. Back to our roller coaster, the energy that we have at the bottom is going to be equal to the amount of energy that we have at the top of the hill. The only difference is the type of energy that is at the bottom is kinetic energy, while at the top it is gravitational potential energy. Get it? Good. Let's look at an example. A vase with a mass of 10 kilograms is sitting on a windowsill 10 feet off the ground. It then falls to the ground. At what velocity did the vase hit the ground? So for this problem, we are going to use the conservation of energy. The vase initially has a lot of potential energy. It is then converted to kinetic energy as it falls to the ground. So the sum of the potential energy initial is going to be equal to the sum of the kinetic energy final. We plug in our mass and height into the 1/2 mgh equation and the 1/2 mv squared equation to then solve for v. Our final answer then comes out to 9.9 meters per second. This is our final velocity. Now we are going to talk about momentum. Momentum is referred to as the quantity of motion an object has. Momentum is calculated by multiplying the mass of an object and its velocity. This means that momentum is a vector quantity, meaning it has magnitude as well as direction, so be careful. Similar to energy, momentum also follows a conservation law. Momentum cannot be created nor destroyed, only transformed. So the amount of momentum you begin with is equal to the amount of momentum you end with. You have a mass of 60 kilograms and are walking down the street with a velocity of 5 meters per second. There is a shopping cart with a mass of 20 kilograms moving towards you with a velocity of 2 meters per second. You jump into the cart. What is the new combined velocity of you in the cart? To solve this problem, we are going to use the conservation of momentum. The sum of your initial momentum and that of the cart is going to equal the combined momentum of you and the cart. So be careful. Since the cart is moving in the opposite direction to you, you will subtract since the velocity is a vector and will be negative. The AdV on the right comes from the total mass of you and the cart, 20 plus 60. Now we solve to get V equals 3.25 meters per second. Now let's look at a combined energy and momentum problem. The ballistic pendulum experiment uses a pendulum to find the initial velocity of a bullet. Someone fires a bullet into a cork block attached to the bottom of the pendulum. Then, they measure the height of displacement of the pendulum to find the velocity using the conservation of energy. Then, they plug this final velocity of the bullet into the momentum equation using the conservation of momentum to find the initial velocity of the bullet. Let's look at an example. A bullet with a mass of 0.015 kilograms is shot into a cork pendulum with a mass of 0.15 kilograms. The pendulum is then displaced 0.01 meters. First, we must find variable Vf, or the final velocity of the bullet and the pendulum, using the conservation of energy. But first, let's write out the conservation of momentum equation so we know which variables to solve for. Now, to find Vf, we're going to use the conservation of energy equation. So, the final kinetic energy of the bullet and the pendulum will equal the initial potential energy of the pendulum and the bullet. We get the 0.165 from the addition of the mass of the pendulum block and the mass of the bullet. When we solve this equation, we get Vf is equal to 0.313 meters per second. Now that we have found Vf, we can plug it in and solve for Vi in the conservation of momentum equation. The initial momentum of the bullet plus the initial momentum of the block, which equals 0 since the block isn't moving, is equal to the combined mass of the pendulum and the bullet times the Vf, which we just found, 0.313. When we solve this, we get an answer that the initial velocity of the bullet is equal to 3.443 meters per second.